really quickly at the beginning. Some things that I would ask you to do when you see a problem like this, an application problem, a problem with many words, we might call it a word problem. Number one, identify some important information. And obviously one of the most important things you can identify is what's actually being asked of you. When we're talking about solving three variable systems, considering what your final answer should be might help you decide a strategy to solve so that you're doing the least amount of work possible. That's not always the case, but it can be helpful. Also, make sure at the end you just don't give me all the information, give me the information I specifically asked for. So I suggest reading the problem, skimming over the problem, and then maybe underlying the question. Okay. Next up, and this one I'm going to push pretty hard on for honors pre-calculus because it's going to be helpful to us next week when we do linear programming, and that's defining your variables. Now, remember that I'm not really teaching you two variable systems because I feel like most of you are professionals at that. But we could certainly have two variable systems, so you might just have an x and a y. Or we could have three variable systems, so you could have x, y, and z. What I'm looking for specifically in defining your variables is deciding what does the x, y, and z represent. So if I'm talking about selling tickets to the school musical, X could be adult tickets, Y could be student tickets, and Z could be senior tickets. So you actually label those things out. So think about those things ahead of time, and like I said, it's going to be really helpful for you to have identified what those things represent when we get to linear programming because there's more stuff happening. Okay? So define your variables. I'm going to be picky about that today. I'm going to want to see that on your papers. Okay. Write the equations that represent the information. That'd be very similar to what you guys did in the warm-up. We didn't necessarily define our variables in the warm-up, but we kind of talked about here. We were just saying A was angle A, B was angle B, C was angle C. And then solve the system using any method of your choice, depending on what answer you're looking for or how the system's set up. Some methods may be more applicable than others. And finally, write and label your answers. Since these are application problems, there's probably some kind of label that you need, whether that's dollars, people, whatever. Go ahead and label that. So the first example, you guys are going to take a trip to Dallas. Woohoo! Excitement, or are you guys all ballot out?
Haven't been there yet.
You haven't been there yet? Okay, so yes, this will pump you up. Get ready to go to Dallas. What I'm going to ask you to do is, I would skim through the problem, looking for important information, also identifying my question, and then you and your group members can work together to define your variables, set up your system, and then solve. I'm going to come around and check, and at some point before you get really into the solving, I'd like to make sure I've checked your system. Okay, so if I haven't come around to check your system, call me over. So I'll go ahead and give you some time to get started. Define your variables, set up a system, and solve. It looks like you guys are doing a great job, so if you're working on solving, you can continue to do that. I'm just going to write up what I saw as I went around the room and talked to each group. Most people chose X to be general admissions, and then Y was the adventure pass. So what those specifically mean is the number of people who came in on general admission, and then the number of people who came on the adventure pass. When you read your word problem, you should pick out some important numbers, 1,262 and 60. Those are like the totals, right? It's the total money that Val's brought in, and it's the total people who passed through the gate. So these 60 people who passed through the gate, it could have been split in half. 30 general, 30 adventure, could have been 50 general, 10 adventure. So one of your equations, and every group had this, was x plus y equals 60. The other equation is all the information you know about what Dallas is raking in, right? They've got their $18.95 that they earn on every general admission, plus the $23.95 they earn on every adventure pass, and that totals $1,692. So if you have two variables, you only need two equations for your system. Okay, this is something you've been doing probably since Algebra 1. Let me ask this question, and some groups are solving and some groups have finished solving. Is there a strategy that you thought of when you were like thinking about what question is being asked and how I want to answer and what I would do to solve? Anybody think about that? If you didn't, focus on the question. What's the question you want to answer? How many general admission passes did they sell? And general admission is represented by which variable? X. So you want to answer for X. What strategy might you use when solving that system of equations to do the least amount of work possible? Nicole says, get rid of the Y's. Okay, you could take your pick, right? Eliminate X or eliminate Y. If you notice in your question that your question is only asking about one specific variable, don't eliminate that variable. If we want to know X, don't eliminate X, eliminate Y. Now, in this problem, is it that big of a deal if you eliminate X? No, because once you find Y, you just have to subtract from 60. So it's not a huge deal, but think about that in terms of like a 3-variable system. If that were a 3-variable system, and you started off by eliminating the thing you were going to solve, then you have to solve the whole thing. Versus if you left that in, that variable you wanted, you'd be able to shortcut yourself. So something to think about, I would probably multiply this first equation by negative 2395 so that I could eliminate Y. What is the value for X if you solve it? X equals 35. If you solved for Y as well, Y equals 25. And you might write that like we practiced yesterday as an ordered pair, 35, 25. But again, in an application problem, make sure that you answer and label your final answer. What do I really want to know? What's my actual answer? A number and a label. 35 general admission. So if I'm answering the question, how many general admissions? 35 general admissions is actually the answer that I want. If you give me one of these, I don't think you've given me a full answer yet. You haven't addressed the question that I asked you. So I would like to see somewhere that you say 35 general admissions. Now, I'm going to take for granted right there that you could solve a 2-variable system. If you need to, go back and do the work for it and ask for help if you need it. I'm actually going to have you go out of order right now. So I want you to flip to the back side. And you're going to do the same thing. I'd like you to work together in your small group. This is helpful because then I don't have to check 25 people. I can check 6 different groups. So what I want you to do in your groups, define your variables, write your system. Before you start solving, get it checked by me. It'll take 2 seconds. Define the variables, write the system, get it checked by me, then I'll have you solve. And go ahead and get started.
No, I think we.
I know people are kind of in the midst of solving, which is great. So I just put up on the board what every group told me around the room. X, Y, and Z are going to represent first, second, third place. And then you have 3 equations. One for the total amount of participants, 20, one for the total number of points earned, that's the one that's equal to 68, and then that last one where we have as many second place finishers, that's Y, as we had first and third, so the total of X plus Z combined. So there are a couple different strategies you could use to solve. You should be working and talking with your groups about strategies, and we'll kind of compare the two methods for solving here just a little bit. Okay, I'm going to interrupt, and I know some people are kind of still on the road to solving there, but I want to talk about this three variable system and what are some options for solving. So can someone describe their solving process? There are really two methods out there. Lauren?
Well, before I even start solving, I rearrange y equals x plus z to equal 0.
Okay.
Find the full diff.
Did you subtract or did you subtract y?
I subtracted x and z.
Okay, so Lauren's going to change, and you can change it a couple of different ways, but she's going to subtract x and z to the other side. That's important if you're going to use the method for elimination, because remember, like what we did yesterday, we chose two equations, we eliminated z, then we chose two other equations and eliminated z again. In order for you to do elimination, variables need to be on the same sides of the equal sign. So you kind of have to rearrange that third equation. So then you went ahead and did elimination twice.
Yeah.
Okay, what's the other method out there, Abby?
Substitution.
Substitution. Describe to us how the substitution works.
So I select the y equals x and z into the first equation, the top one, and solve that, and that negative x equals 10 equals z.
Okay, so what Abby's talking about is you have one equation that says y equals x plus z. If you plug x plus z then in for y, you're going to create an equation that has only x's and z's. Isn't that the same goal of eliminating? To have only two variables? So this would work out, it comes out to be 2x plus 2z equals 20. And then you would just do substitution again. Okay, so substitute into the second equation, 5x plus 3 times x plus z equals 68. And then distribute and combine like terms, so you get 8x plus 4z equals 68. Okay. And you have two equations there that you could work with to do the two variable system. What's that ordered triple that we get for this one? What's the answer? 7, 10, and 3, and when you're thinking about answering the question for an application problem, you should have some kind of label. So 7 first place finishers, 10 second place finishers, and 3 third place finishers. Okay. Yes, Maggie?
About 5, 10, and 5.
I will look at yours and find an error. How about that? Don't erase everything. Any other questions about solving methods that I can answer there? Okay, here's the reason why I went out of order. Number 2 is actually page 496, number 62. It's not a required problem on your homework, but it is on the gold sheet for your homework assignment. So we have about 7 minutes remaining in class. If you don't want to get out a textbook and get started on your assignment, then I expect you to be working on example 2 on your notes. If you'd rather get out the textbook and get started on your assignment, there's a couple extra textbooks over there behind Caitlin. You can share at your tables. You can get started on some of those problems. As a group, you might work together to write the equations so that you're ready to go for solving tonight.